Hello everyone, welcome to the class once again. I hope you are all doing good and in the best of your health. So I believe that you have seen all the classes on this chapter, thermal properties of matter, and you will be thorough with all the concepts that we have discussed in this chapter. We have discussed about black body radiation, we have discussed about Kirchhoff law, Wien's displacement law, and linear expansion and so many things in this chapter. We will be discussing question in this exercise based upon JEE main pattern exercise. That is, question will be of single choice option where one option will be the correct answer, rest three options will be incorrect. In a JEE main examination, let me tell you, one question or at least 2 to 3 questions will be definitely coming from this chapter. So you should be thorough with each of the basic concepts that you have learned in this chapter. The question that we are going to discuss today have been arrived in the previous examination and they would match with the JEE main standards. Let's go with the first question of the day. We have first question, variation of radiant energy emitted by sun, filament of tungsten lamp and welding arc as a function of its wavelength is shown in figure. You can see a figure here about this. We have been describing that how the variation of radiant energy is varying with lambda. Which of the following options is the correct match? A, sun T1, tungsten filament T2, welding arc T3. B, sun T2, tungsten filament T1, welding arc T3. Sun T3, tungsten filament T2 and welding arc T1. Sun T1, tungsten filament T3 and welding arc T2. So here how to comment on which option is the right answer. Before that, let me show you about the Wien's displacement law, how lambda and intensity varies. We have seen that already. Such kind of curve you must be remembering in our regular classes we have discussed. For minimum value of lambda, the temperature into this lambda is constant. This is as per Wien's displacement law. This is the Wien's constant, that is B, I have written here. So lambda into T equals to B, that is what we know about the Wien's displacement law. If any other curve you want to talk about, the temperature is T. If I draw any different curve, then we'll be having, let's say this is also one more curve we have here in this case. Or let me draw a very appropriate curve so that you will not get confused, so that we may get an idea about the temperature variation. Let's say this is another curve at temperature T2. This is temperature T1. Here we have temperature T2 and here let's say it's lambda m, or it's better to use T and T dash. That would be more better, T and T dash. So here we are having, let's say, lambda dash m. So lambda dash m, it's smaller, so temperature T dash will be higher than compared to temperature T. So we can also write, quite obvious, lambda m dash is smaller, so temperature T dash has to be higher because both are constant. Lambda into T equal to B, that is constant. Now, what we are seeing that as lambda reduces, temperature T moves higher. Here you see, although this question has come in the previous examination, this curve was given in this way, you have to take that this curve will somewhere at very top, it will be at the extreme left. Its topmost portion, if I draw appropriately, it will be extreme left, or let me draw from the other end so that you may get it clearly. Something like this. So lambda minimum will be minimum for T3 temperature. So it's minimum for T3 temperature, and then we have for T2, and then the maximum we say lambda is for T1. So if I write lambda variation, it will be lambda 3 will be lesser than lambda 2 will be lesser than lambda 1. So from Wien's law, from Wien's displacement law, we can comment on the temperature that will be T3 will be highest than T2 than T1. So T3 will be highest. See the three places from where radiation energy is given. Radiant energy, and you can directly relate radiant energy with the intensity. That is what directly you can do. Radiant energy of 3 sun, filament of tungsten lamp and welding arc. We all know that sun will be having the highest temperature, and highest temperature in this case is T3. So T3, you see sun is matching with T3, option number C clearly matches. So tungsten lamp and filament, although for welding arc is not given, you have to take that tungsten filament temperature will be T2 and welding arc will be minimum, that will be T1. Hence, you have to choose option number C as your right answer. This is how logically you have to approach. Rest all options are incorrect. So you should know how Wien's displacement curve is utilized in evaluating the answers of such questions. Let's go ahead with the next question of the class. I believe that this is clear to you all. Let's go ahead with the next question. Question number 2. 3 rods made of the same material and having the same cross section have been joined as shown in figure. Each rod is of the same length. The left and right ends are kept at 0 degrees Celsius and 90 degrees Celsius respectively. The temperature of junction of the 3 rods will be A. 45 degrees Celsius, B. 60 degrees Celsius, C. 30 degrees Celsius, and D. 20 degrees Celsius. So 3 rods you have 1, 2, 3. Now if I draw separately, let me show you all here. The case is somewhat like this. 3 rods, 1, then we have second, then we have a third one. These are the 3 rods that has been provided to us. Now it says that the temperature at this part is 90 degrees Celsius, 90 degrees Celsius, and here we have 0 degrees Celsius. Let's say the temperature junction, the junction temperature is theta. It's required that the temperature of junction of the 3 rods will be. Now you see the 3 rods are of same material, having the same cross section, and have been joined as shown in the figure. Having same cross section, that means having the same area of cross section and having the same length. That is what we can, and each rod is of the same length also, that's given separately. Now you know that if the rods are of same material, same length and same area of cross section, their resistance will be equal. Resistance of all the 3 rods will be equal. That is what we can make out from the given thing in the question. Now if the resistance is equal, now see here, obviously heat is going to flow from this end to this end, heat is going to flow from this end to this end. Let's say the rate of heat flow from this end is Q1, it's Q2 from this end, and here it's Q. Quite obvious, we can say that Q will be equal to Q1 plus Q2. Now we all know that how to write this. We can write this as the rate of heat flow as, we can write that the difference in temperature divided by the heat resistance. So equivalent, now see, Q will be equal to the value of temperature difference will be theta minus 0. So I can write theta minus 0 divided by the resistance, that is R. Q1 can be written as 90 minus theta plus 90 minus theta for one other. Q1 and Q2 we have written this way. Clearly you can see that R and R will be cancelled out. Theta will come out to be 180 minus 2 theta. So we can write theta is equal to 180 minus 2 theta, or 3 theta will be equal to 180, theta will come out to be 60 degrees Celsius. Theta equals 60 degrees Celsius, that means the temperature of the junction is 60 degrees Celsius. Let's check with the option. A 45 degrees Celsius, incorrect. B 60 degrees Celsius, yes, that's right. C 30 is the incorrect option, and D 20 degrees Celsius is the incorrect answer for this. So you should know how the heat current flows through each of the conductors. As per this, proceed with each of the step, you are going to get the right result. The temperature of the junction, that is theta we have taken, that comes out to be 60 degrees Celsius. That is what we obtain here. Next, let's go ahead with the next question of the class. It's a good question to understand the heat flow, and concept of conduction is used here. We have discussed this in our regular class, and I hope that you will find it easy to do it. Next question, question number 3. The plots of intensity versus wavelength for 3 black bodies at temperature T1, T2 and T3 respectively are as shown. The temperatures are such that A, T1 greater than T2 greater than T3, B, T1 greater than T3 greater than T2, C, T2 greater than T3 greater than T1, and D, T3 greater than T2 greater than T1. Now here in this case, you need to see again this is a curve between lambda and intensity I. Already we have discussed such kind of curve for Wien's displacement law, and let me draw the curve once again so that you may have a clear idea with intensity relation of lambda. We have discussed that if a curve is there, this term lambda m is there. So from Wien's law we know that lambda m into T is equal to constant. This is what we know, lambda into T is equal to constant. Next you see here, that means the minimum value of lambda will be having the maximum temperature. So T1 will be the maximum, then we'll be having T3 and minimum temperature will be T2. So T1 is greater than T3 is greater than T2 as we observe. So if I mark here lambda 1, lambda 2 and lambda 3 for 3 cases, lambda 1, let's say this is lambda 3, this is lambda 2. So lambda 1 will be the minimum, lambda 2 is the maximum. So we can write lambda 2, then lambda 3, and then we have, lambda 2 is the maximum. I should draw in this way. Lambda 1 is the minimum. So since temperature and lambda are related inversely, so we can write T2 and T3 in this way, and T1 will be the highest temperature. We have discussed such kind of question. T1 will be the highest temperature, then we will be having T3. So T1 is highest, and then T3 we are having, and then T2. Option number B. The rest you see, T1 is highest here, but here is given T2, so incorrect. This is T2 is highest, so incorrect, and here T3 is highest, so this will be incorrect. So if you know about Wien's displacement law, if you know about the curve, you will get the right answer. That is option of B will be the right answer for this question. So I believe that you've understood how to use the concept of Wien's displacement law. And let me tell you, questions in this chapter are not too tough, but it will be conceptual. If you have understood each of the concept with depth detail in this chapter, you can easily answer question in your JEE main examination and if JEE advanced examination also. Let's go ahead. Fourth question. Parallel rays of light of intensity I equals to 912 watt per meter square are incident on a spherical black body kept in surrounding of temperature 300 Kelvin. Take Stephen constant sigma equals to 5.7 into 10 to the power minus 8 watt per meter square per Kelvin power 4 and assume that the energy exchange with the surrounding is only through radiation. The final steady state temperature of the black body is close to A 330 Kelvin, B 660 Kelvin, C 990 Kelvin, and D 1550 Kelvin, that is 1550 Kelvin. Now how to approach such kind of question? First of all, see there. Parallel rays of light of intensity I equals to 912 watt per square meter are incident on a spherical black body. On a spherical black body, they are incident kept in surrounding of temperature 300 Kelvin. Now see here. Spherical black body. This is a black body, spherical black body. Let's say its radius is given as R. Parallel radiations are incident on it. Intensity 912 watt per square meter. This is given to us. Now see, they are following on this hemispherical area, and if you see that, we know that energy incident will be equal to intensity into area, energy incident per unit time. So as per Kirchhoff law, we can say that energy incident will be equal to energy radiated. Energy incident will be equal to energy radiated. Now see that how to use. The surrounding temperature is given as 300 Kelvin. This is what that has been given. Let's say the surrounding temperature is T0, that is 300 Kelvin. Energy incident I. Now what area to use? 4 pi r square is the entire area. Now these are parallel rays. Don't think that you have to use 2 pi r square. The effective area will come out to be pi r square only. the effective area will be pi r square only, so use it, pi r square is equal to energy radiated. We all can use here sigma A T to the power 4 minus T to the power 4. This is what we can use. The temperature, loss in temperature will be in this way, sigma A T power 4 minus T naught power 4. So everything is given to us, and see that area, what area we have to use. The area used will be here, that will be 4 pi r square, because the entire region the energy will be radiated. So let me just frame this equation once again in a proper manner. I will be rubbing this part, and let me write here I into pi r square. I into pi r square will be equal to sigma into 4 pi r square multiply with T power 4 minus T naught to the power 4. From here, terms that will be cancelled out. You will be having T to the power 4 minus T naught to the power 4 is equal to I by 4 sigma. This is what you can make out. Next you see T to the power 4 is equal to T naught to the power 4 plus I by 4 sigma. That is what you have to use. And let's go ahead, T naught to the power 4, that is 300 to the power 4, and I value is 912 with proper SI units, 4 into value of sigma 5.7 into 10 power minus 8. Put it here, 5.7 10 power minus 8. This is what you can do. Here you will be getting this is equal to 3 to power 4 will come out to be 27, and 27 multiplied by 339, 9 into 9, sorry, this will be not 27, 3 into 3, 9, 9 into 3, 27, 27 into 3, 81. 81 into 10 to the power 8 plus you will be having 912 divided by this much. That will come out to be nearly, if you solve this, that will come out to be, if you solve this exactly, this will be somewhere around 40 into 10 to the power 8. That is what you will be getting, 40 into 10 to the power 8. So finally this will come out to be 121 into 10 to the power 8. So we have less space here, I will be using this part. The result that you are going to get, T to the power 4 is equal to 121 into 10 to the power 8, that is what you are going to get. So finally, if you go ahead, if you solve this, you will get somewhere the result that will be nearly to 330 Kelvin. You solve this temperature, that is, you can follow the steps, you will be getting this as the answer. It will be somewhere around 330 Kelvin. Let's see at the option A 330 Kelvin, that is the right answer. B 660 Kelvin, no. C 990 Kelvin, D 1550 Kelvin. If you are thinking that in JEE examination how to solve this, so you have to reach an approximate result from this equation. If you are thinking that which option to choose, because the options are variable, the difference in two options is quite large, you can comment on which option is closer and you can tick which option will be nearer to the right answer. 330 Kelvin, that is the right answer you are getting. So this is how logically you have to choose on the day of your examination. We will proceed with the next question. And I believe that you are learning with each of the questions discussed in our regular classes that we are seeing here. Next question, question number 5. Two rods, one of aluminium and the other made of steel. We have two rods, one of aluminium and the other made of steel, having initial length L1 and L2, are connected together to form a single rod of L1 plus L2. The coefficient of linear expansion for aluminium and steel are alpha A and alpha S respectively. If the length of each rod increases by same amount when the temperature are raised by T degrees Celsius, then find the ratio L1 upon L1 plus L2. It's A alpha S upon alpha A, B alpha A upon alpha S, C alpha S upon alpha A plus alpha S, and D alpha A upon alpha A plus alpha S. 4 options we have been provided, and which one to choose? L1 upon L1 plus L2 option we need to, L1 upon L1 plus L2 we need to check. Now see here, L1 upon L1 plus L2, that is the length that has been given. Now see, It's given that the expansion in aluminium is equal to the expansion in steel. So I'm writing delta L is equal to delta L of steel. Delta L of aluminium is equal to delta L of steel. That is what is given. Aluminium and steel we need to check. Clearly we know that delta L is equal to L alpha delta T. This is what we know. Now delta LA is equal to delta LS. If we use delta LA is equal to delta LS, so then we will be having LA alpha A T is equal to LS alpha S T. That is what we can do. Now LA is what? L1. Just I am writing the exact terms given in the question. So if I write L1 by L2, or if I write L2 by L1, let me write L2 by L1. L2 by L1 will become alpha A by alpha S. If I do here plus 1, we should also add here plus 1, alpha A by alpha S plus 1. This will become L1 plus L2 divided by L1 is equal to alpha A plus alpha S divided by alpha S. Hence, L1 upon L1 by L2 will become alpha S upon alpha A plus alpha S. This is what the option we are getting. L1 upon L1 plus L2 is equal to alpha S upon alpha A plus alpha S. Now see here, let's say the first option, alpha S by alpha A, no. B, alpha A by alpha S, no. C, we are having alpha S upon alpha A plus alpha S. We are having here alpha S upon alpha A plus alpha S. You can see here. So alpha S upon alpha A plus alpha S, that's the right answer. If you check with option number D, alpha A upon alpha A plus alpha S, no. This is not the right answer. We are having this one is the right answer. So the direct answer you cannot reach in this question. You have to convert the ratio so that you can get the final answer. The thing is hidden in the question how to approach. It says that the expansion in each rod, if the length of each rod increases by the same amount, when the temperature is raised by T degrees Celsius. So temperature raised is same, their length is increasing by same amount. So you have to use delta L in 1 is equal to delta L in 2. So these were the first 5 questions that we have discussed in the exercise. For the next 5, I'll meet you in the next class. Till the time you keep revising, see the regular chapters that we have discussed, see the concepts, try to by heart some basic formulae, do practice question on your own because that is what is required. When you practice question on your own, you will understand how to solve them and how to make an approach. And as you practice more, you will see that accuracy will be enhanced and speed will automatically come in your practice. So this is all in the first 5 questions we have discussed in the class. I'll meet you all with some more questions, with some more concepts in the next class. Thank you everyone for joining me. Wish you all the very best.